Hey, good afternoon. We're talking about our congruent shapes and our transformations. So we just finished up with congruent figures, and now we're going to talk about transformations. And transformations are just different movements that we can do with our figures. So maybe I could flip it, or I could turn it, or I could move it around, across the page. And here's an example of this. This is like a marching band dot chart. So if you're in the marching band, you get this chart. And it has the original formation, and then I always had it where you would flip the page and you would see the next formation. We never had those little vectors on there, or those arrows, but you would see your formation, and then you would flip the page and you would see the next formation. And what I want to look at is, what are some of the similarities and differences between these two pictures? So why don't you pause the video, get a couple sentences written down. What are the similarities and differences between the pre-image and the image? All right, so you should have written down a couple sentences. If you haven't, just pause the video again. Otherwise, we are unpaused. So we start off with our pre-image in a transformation. Start off with our pre-image and we end up with our image. And if you notice here, these are the same size. So same size and shape, which means they are congruent. That was our informal definition of congruence. If they're the same size and shape, those are congruent figures. But here we have two figures, the pre-image and the image, that are the same size and shape. It's just one moved up and to the right. And when we do that sliding motion, that shift up and to the right, we call that a translation. So we start with our pre-image, and we translate it to our image. And if you see these vectors, these arrows, are telling me how everything's going to move. So those arrows are pointing to where I'm going to end up. See, I start here, I end at the tip of that arrow. I start here, I end at the tip of that arrow. Start here, end at the tip of that arrow. Or I start at X, I end over here. So those are our vectors. These arrows, these rays, those are vectors that tell me how I'm going to move my shape or my figure. I'm starting with A, B, and C, and I'm going to move this over 2 units to the right. And my pre-image is ABC. My image, we always use these little apostrophes for our image points. And we call that A prime and C prime and B prime. The standard joke is, A goes to A prime, B goes to B prime, Optimus goes to Optimus prime when you're doing a transformation in geometry. So anyway, it's kind of a dumb joke, but I like it. I'm going to move it 2 units to the right, and let's find our new coordinates. So A is 0, 3. I just moved it to the right. I did not move it up or down. B is -2, -2, -1, and C is 4, -2. So notice that this is the same size and shape. I just moved it 2 units to the right. And what do you notice about these numbers? What do you notice about those numbers? I moved it 2 units to the right, or 2 units in the X direction, because it's my X axis. So when I moved it 2 units to the right, what happened to those numbers? Well, I just added 2 to my X coordinates. Because if I'm moving left and right, I'm moving in the X direction. I'm moving along the X axis. So I'm only going to affect the X coordinates. I didn't change the Y coordinates. just the x. All right, so let's get some vocabulary down. Our main ideas is that a translation, that sliding or that shifting, a translation is a vertical or horizontal shift of a figure. And our rule, we're given a rule that helps us to find our image from the pre-image. We take x and y, and I'm going to add some horizontal shift or subtract, and I'll add or subtract some other number from y. All right, and let's look at an example here. I start with QRST, and I'm going to go to Q prime, R prime, S prime, and T prime. Just like we said, this is our image. The primes are our image, is our ending point, and the pre-image, our starting point, is always just regular old letters, always capital. So look at our rule highlighted in orange. XY goes to x plus 5 and y plus 7. So I'm going to start with Q, -6, -1. I'm going to use that rule. -6 plus 5 is -1, and -1 plus 7 is 6. All right, let's do the same thing over here. R, -3 plus 5 is 2. 1 plus 7 is 8. Okay, I wish my keyboard would stop doing that. S, 1 plus 5 is 6. -5 plus 7 is 2. And last but not least, -2, -7. -2 plus 5 -2 plus 5 is 3. And -7 plus 7 is 0. And notice that the blue picture is the image. I moved it right 5 and up 7. And all we're doing here is just our addition or subtraction. We have to be careful about the negatives, though. Let's try one more example. Why don't you pause the video and try this one, and then unpause it and check your work. 2, -1 is C, so C prime, I'll take 2 minus 3 is -1. 2 minus 3 is -1. -1 plus 8 is 7. D prime, 7 minus 3 is 4. -4 plus 8 is 4. And E prime, 4 minus 3 is 1. And -6 plus 8 is 2. Check out your image and pre-image. How do I find which one's the image? That's the one without the apostrophes. That's just regular old P, Q, and R, whereas your image is going to be P prime, Q prime, and R prime. And let's see, how do I move from P to P prime, or from R to R prime, or Q to Q prime? Let's do Q. So I'm going to move here. This is where I go from Q to Q prime. So I go right 1, and I go down 1, 2, 3, 4, 5, 6, 7. Down 7. So right 1 and down 7. Well, how do I represent that? In the X direction, how do I represent right 1? Well, it's going to be either adding or subtracting, and if I'm going to the right, which one would that be? Well, that would be plus 1. And then Y, I'm going down, should be minus 7. So let me know what questions you have. Check out your answer key, the homework answer key. Send me an email, join office hours, or otherwise let me know that you have a question you want answered, and I'll do my best to help you out. I will see you guys tomorrow, and I hope you have a fantastic break.